In class, we've been doing a lot of practice of actually solving multi-step equations, and so today we're going to review how to justify solving those equations with the algebraic properties. So those are like properties of equality, adding a number to both sides of the equation, commutative property of addition, all of that stuff. So we're going to do a refresher on this because I know we've done this before, but it's been a little while. So when you're justifying solving, we're looking at what is changing from one step to the next. So in this first example, let's say we're moving from the given to step one. So this is just the given. This is what's provided to us. This is the original equation. And we're looking at, well, what changed from this given step to step one? What did they do? So looking at 2x plus 4 equals 12, it looks like what changed is they subtracted 4 from both sides. And that's what they did. They did that using the subtraction property of equality. And I just abbreviate property of equality with POE. But if you're going to abbreviate subtraction, at least put subtract, because there's another property called substitution that if you just put sub, I don't know if you're saying subtraction or substitution. All right, so let's look now from step one to step two. So what changed from those two steps? Well, that minus 4 is still there, but this minus 4 is gone. In fact, this 12 minus 4 became 8. So 12 minus 4 became 8. So they replaced 12 minus 4 with 8 because 12 minus 4 is equal to 8. So that is substitution. So anytime we're just adding or subtracting, we're combining like terms, we say that substitution because we're replacing a expression with its equivalent number, with what it's equal to. All right, going from step 2 to step 3. So the 8 stays the same, but it looks like what changed is positive 4 minus 4 became 0. So positive 4 minus 4 became 0. So what property says that a number and its opposite make 0? That's the additive inverse. Additive inverse. A number and its opposite equal 0. And you also might see this written as inverse of addition. All right, moving on. Let's go from 3 to 4. What changed here? Well, the 8 stayed the same, but this changed. 2x plus 0 just stayed 2x. So 2x plus 0 just stayed 2x. So what property says that any number plus 0 stays itself? That's going to be additive identity. Or you could say identity of addition. Identity property of addition. All right, how about going from step 4 to step 5? What changes there? Well, the 2x and the 8 are still there, but now they're being divided by 2. So both sides of the equation are being divided by the same number, and that's the division property of equality. The division property of equality says that we can divide both sides of an equation by the same number and the equation still stays true. All right, let's go from 5 to 6. So a couple things changed here. So first, 4 is new and 1's new. So where did those come from? Well, 8 divided by 2 gives us 4. And 2 divided by 2 gives us 1. So it looks like we've replaced 8 divided by 2 with 4 and 2 divided by 2 with 1. So what property says we can replace an expression or replace something with a value that's equivalent to it? That's substitution. Again, we see substitution when we're just simplifying things. We're dividing, we're adding, we're subtracting, and we're not necessarily doing the same thing to both sides of the equation. We're just saying 8 divided by 2 is 4, and 2 divided by 2 is 1. All right, last step. Step 6 to step 7, what changes? The 4 is the same, so it's not going to be there, But how about this? 1x became x. So what property says that 1 times x is equal to x? Anything times 1 stays itself. That is the multiplicative identity, or identity property of multiplication. Anything times 1 stays itself. All right, let's do another example. This one's going to be a longer example, but it shows you a lot of different properties, so that's why I like to use it. So to start off, we have a given. Okay. And let's look from the given to step 1. What changed within the problem? Well, the 12 and the 4x aren't really messed with, but this changes. The 2 times x minus 3, that became 2x minus 6. What property allows us to do that? And that's going to be the distributive property. All right, let's go to step 1 to step 2 now. What changes? Well, the 12's the same, the 2's the same. Oh, but negative 6 plus 4x now became plus 4x minus 6. So we changed the order. What property allows us to change the order of things in which we're adding? How about commutative of addition? Commutative of addition. We can abbreviate addition. But make sure you put addition or a plus sign or add, because there's commutative of multiplication, and if you just put the commutative property, that's not the answer, because we don't know specifically which commutative property was used. We have to know that. Step 2 to 3, what changes? Okay, the 12's the same, the 6 is the same. Oh, but 2x plus 4 now became 6x. So we added 2x plus 4x. So we took 2x plus 4x and we replaced it with 6x. What property allows us to replace an expression with an equivalent value? Substitution. So we use substitution when we're combining like terms. And you don't have to necessarily write combining like terms. I want us to get in the habit of thinking about it that way. If we're just combining like terms, it's just substitution. 3 to 4. So what's new from 3 to 4? There's actually something that's completely new to the equation, this plus 6 on either side. So the property that says we can add a number to both sides of the equation is the addition property of equality. I can add any number to both sides of the equation. In this case, we can add 6 to both sides. Okay, let's go to 4 to 5, step 4 to step 5. The 12 plus 6 stayed the same. The 6x stayed the same, but this changed. Negative 6 plus 6 became 0. Negative 6 plus 6 became 0. A number and its opposite became 0. That's inverse of addition, or additive inverse. If you noticed in the last example, I wrote additive inverse, and in this example, I wrote inverse of addition. I just want you guys to be familiar with both of those ways to write it and know that those are both correct. So in case you see, like on an assessment, you see inverse of addition and you're like, oh, I thought it was additive inverse only. It means the same thing. So I want us to be familiar with writing it those different ways. Okay, next one. Let's go from 5 to 6. Let's see, what changed? What changed? All right, the 12 and the 6, those are the same, but this changed. 6x plus 0 became 6x. So 6x plus 0 stayed 6x. A number plus 0 stays itself. Identity of addition. And again, identity of addition is perfectly fine. It's a perfectly fine way to write it. You also might see it as additive identity. I want you guys to be familiar with both ways of writing it. right, how about 6 to 7? 6 to 7. All right, so the 6x here stays the same. So let's look over here. 12x plus 6 became 18. So it looks like 12, or I'm sorry, not 12x, just 12 plus 6 became 18. All they're doing is combining like terms. And anytime you're combining like terms, all that is substitution. Because you're replacing an expression with an equivalent term. All right, 7 to 8. Let's see what changes. All right, so the 6x is there, the 18's there, but whoa, there is something brand new to this problem. 1/6 on both sides. Now, here's where some people will automatically say, oh, it's division, property of equality, because 1/6 as a fraction means dividing. But let's look at what that 1/6 is actually doing to both sides. This is saying 1/6 times 6x because of those parentheses, and 18 times 1/6. So this is actually multiplication, property of equality, because we're multiplying both sides of this equation by 1/6. It doesn't matter whether 1/6 is a fraction or not, you're still multiplying by that fraction. All right, so what changes in the next step? Let's see. So that was 7 to 8, now we're going to go 8 to 9. So 18 times 1/6, this looks the same on this side, okay? So that's not really going to help us determine what property was used, but this is totally different. 1/6 times 6 became 1. So I'm going to rewrite that. 1/6 times 6 equals 1. 1/6 times 6. How are 1/6 and 6 related? Well, they're inverses of each other. They're multiplicative inverses. They're reciprocals. So this is the multiplicative inverse. I'm going to abbreviate because I ran out of room. Multiplicative inverse. You could also say inverse of multiplication. All right, step 9 to 10. This doesn't change, but 1x became just x. So 1x became x. A number times 1 stays itself. Multiplicative identity. Multiplicative identity. A number times 1 stays itself. And then very last step, 10 to 11. The x doesn't change. This is what changes. 8 times 1/6 became 3. 18 times 1/6 became 3. All we're doing is simplifying. We're just multiplying. We're carrying out a basic operation of multiplication. So that is going to be substitution. Because we are substituting the number 3 in for the expression 18 times 1/6. So a couple of properties we didn't see in our examples, just to briefly remind us, let's say you had an example like x equals x. Well, that's just the reflexive property. The reflexive property of equality. Or let's say we had this, x equals 2. If x equals 2, then 2 equals x. We're just switching around the equal sign. It's kind of like it has a line of symmetry, and it's switching around that line, so that's the symmetric property. Symmetric property of equality. And then, very last one, if A is equal to B, B is equal to C, then A is equal to C. Transitive property of equality. Hope that helps. Have a great night.